All right, let's get started. I'm here, you're here. Let's get going. Good morning, everybody. Welcome to another exciting morning of chemistry with your host, me, Dr. White. For those who are watching the video, well, good afternoon, good evening, or good whenever. All right, this Thursday, I'll be giving test number 2 like I did test number 1. After class, I'll send out the password sometime tomorrow. I will be posting or putting in the assignment area test number 2 as a PDF file, which will be password protected. Thursday after class, I'll send out the password, and you'll have until Friday, 10 a.m. to get it done. I think that's more than enough time. Shouldn't take you more than an hour to do it. If you want to take a few more minutes, don't tell me and I'll let you do it. But uh, let's go through. Hopefully you saw it. If not, let's take a look at it. All right, everybody see Chem 1211 test number 2 information on the screen. Thank you. All right, let's go through. Like I just said, you'll be taking it on Thursday. You have until 10 a.m. Friday to hand it in. It'll cover chapters 5 through 10, which really includes chemical bonding, which is ionic and covalent bonds, also Lewis structures, and ions form, ionic and covalent. I'll be doing my review in a little while. And it has 21 problems, 9 pages. There are no multiple choice, but some of the questions are multiple part, like A, B, and C, but not multiple choice. It will have the various topic areas, chemical bonds and related topics, 49 points, mole and mole related topics, including balanced chemical reactions, 56 points. And look, it adds up to 105. So there's 5, yes, 5 bonus points. See, it even says it on the screen. Oh, that was late. Remember, use proper significant, it'll say this on the test, but use proper significant figures for all calculated answers and use 3 significant figures for all atomic masses. You'll be given my green periodic table to download. You've seen it before. On the top of each column, it has, if you don't know your Roman numerals, the numeric, just regular number for the number of valence electrons. Important, please upload your test as a single PDF file. If you don't follow instructions, I reserve the right to subtract up to 25 points from anybody who doesn't follow instructions or doesn't get it on time uploaded. And like I said, I'd recommend you download on Wednesday the PDF file and the periodic table file. If you have any questions during the test, by every other hour, maybe every hour, I'll be checking my email. Email me. There will be a Thursday Zoom lecture. We'll go through new stuff that won't be on test number 2. Plus, we'll do our lab. I should get all the scores in by Sunday, 1 p.m. or sooner. I'll send out an email, an announcement when you can look at your grades. On Tuesday, after the test, a week from today, I'll go over the whole test like I did test number 1, but I will eliminate those tests going over test number 2 answers from the video. If you need to see them and you couldn't make it to the lecture, Zoom lecture, come to my office hours. Also, quick commercial from Dr. White. Tomorrow night, I will have my office hours from 6 to 7:15, and feel free to come. Now, one thing I noticed last night, if I'm talking to a student during my office hour and you show up, stick around. I try and give everybody equal time during my office hour. Oh, by the way, if you don't know by now, I play favorites. All my students are my favorites. All right, any questions about test number 2? Going once, going twice, done. All right, today the game plan is, first of all, I'm going to do my world famous review for next test, test number 2. If I remember correctly, everybody liked that review and wanted me to do another one. So back by popular demand, I'll be doing my test number 2 review. After that, I'll be going through chapter 8 practice problems. And then after that, if we have time, which I bet we might have some, I'll be going through the gas chapter that I started the last time we met. And that's today's fun schedule. If I say fun enough, you might believe me. One thing I do want to point out, thumbs up people, do you see important information test number 2? Thank you. I guess nod your head people too. All right, if you haven't looked at this, you should. This is in the lecture file of Blackboard for our course, and it's got the unique name, test number 2, important information. This will be the last 2 pages of your test that you'll be taking. This is stuff you don't have to memorize, but you should know how to use. And I would ask you to go through and look at this, and this should help you out. Like I have here, all the different mole relationships, how to do mass calculations for reactions. We'll do that in chapter 8. And how to do limiting reactants. We'll do that in chapter 8 today. But like I've said a number of times now, I'm testing your knowledge of chemistry. I'm not testing your memory. All right, let's go through test number 2 review. But before that, a caveat from Dr. White. If you don't know what the word caveat is, look it up in Google. You're college students, you should know what that means. And that is, the last time I checked, I don't walk on water, especially with my back, I wouldn't. I don't walk on water unless it's frozen, really not. And even then I stay off it, which means once in a while, I might forget something on the review that we've covered in lecture. And if I do that, it's still fair game for the test. It's rare, and I don't think I did for this review, but you should remember every concept on any one of my tests and final. But test number 2, I have covered that concept for that problem at least twice, more than twice. And well, you know, Dr. White believes repetition is good for your grade. Also helps you learn it. All right, let's go through this. Test number 2, a review. We talked about where are the electrons. The electrons in an atom of an element are in the electron shells. The shell is where you have approximately, this is the same distance, same energy of electrons in there. Now, the shells have very fancy names, 1, 2, 3, 4, and the number of subshells in each shell. Shell 1 has 1, 2, 2, 3, 3, 4, 4. Now, subshell names, part of it is SP, D, and F. And it goes from S is lowest to F is highest energy. And these are orbitals or subshells. And here I have the same thing. Now, subshell S can have a maximum of 2 electrons, P, 6 electrons, D, 10 electrons, F, 14 electrons. Don't forget, my gift to you is you only have to know up to magnesium 12. I'm not doing the rest of the periodic table because I'd rather spend your time on other things that are more important. So shh, don't tell anybody I'm being nice. It'll ruin my image around you. I got to bring my bullwhip to class to bring back my image. And yes, Dr. White knows how to use a bullwhip. One of my hobbies is unusual weapons. I can use bullwhips, boomerangs, and nunchucks quite well. All right, let's take a look at some, by the way, don't forget, a subshell is actually the name of a subshell. The correct name is both a number and a letter. Oh, look, the bee jumped up. Anyways, let's do one. I should have printed. Oh, sorry about that. This is draw the electron configuration for, hold on, let me reposition my tablet, for carbon. And now when you're doing electron configuration, that's all the electrons. And if we look at our periodic table, once I open it up, hang in there. Everybody see the periodic table? That's funny. Zoom says you should. Let's do it again. Now do you see it? Thank you. All right. Now, for doing electron configuration, you need the number of electrons. Remember, atomic number gives you the number of electrons, number of protons. Notice for carbon is 6. So we have 6 electrons to put in. The first shell is 1, and the first subshell is 1s, letter and number. How many electrons can we put in any s orbital? 2. So I'm going to put that in there. Am I done? No, I need 6. How many subshells does 1 have? 1. Well, I filled it up, so now I have to go to shell 2, which has 2 subshells. So what's the first subshell in 2? Remember, you go lowest to highest, and that would be 2s. Remember, subshell name is both a number and a letter. How many electrons can I put in 2s? 2. Do I have 6? No, 2 plus 2 is 4. So 2s is full. And what's the second subshell in 2? Well, it's 2p. How many electrons can I put in 2p? 6, but I only have 2 left to go. So, and that's how you do it. And like I said, electron configuration is a statement of how many electrons an atom has in each of the subshells, hint, number and letter, and superscript numbers. Oh, I followed my hint. Next, we talked about valence electrons. you should know what is a valence electron, and that is the outermost electrons of an element. How do you find the valence electrons? You look at the periodic table and look at the top of the column of the periodic table. And if we look at our periodic, everybody see the periodic table? Thank you. And if we look at nitrogen, how many valence electrons nitrogen? 5. If we look at bromine, look at top 7. Now, I realized a couple of years ago that they had been teaching Roman numerals for a while, which is why I put the numbers up here, because you see each of these has printed on the one I have, the Roman numeral, IV is 4, etc. If we come over here, magnesium has 2 valence electrons. And when we do Lewis structures, you write the chemical symbol, and then 1 dot, use only valence electrons. Common mistake, test numbers 2, students use all the electrons. No. For carbon, you don't use 6, you use 4. Then put 1 dot on each side before doubling up. So if I were to do chlorine, oh, let's do iodine. And iodine has 7 valence electrons. Let's see if Dr. White's lying to you or not. Can everybody see how many valence electrons iodine has? It's right here. Look on top. Oh, look, I wasn't lying to you. Isn't that nice? Look out, it's poor humor Tuesday. And how do you do that? Oh, wait, I'm going to let you try it. Draw the valence, the Lewis structure for iodine. Uh-oh. Now you see it. All right, everybody done? Nobody's screaming at me. Wait, wait, wait. All right, let's do it. We have 7 valence electrons. Doesn't matter which side you start, put 1 on each before you double up. That's 4. And now I'll do 5, 6, 7. This is one way. Another way could have been this. And there are 2 others I could draw. All would be correct. And that's how you do valence electrons. Now, when it comes to chemical bonds, you should know there are 2 types. One is ionic bond, and you should know an ionic bond is the transfer of 1 or more electrons from one atom or group of atoms to another atom or group of atoms. So one type of chemical bond is ionic. The other is covalent, and you should know this results, or the covalent bond is the sharing that's important, as opposed to transfer of 1 or more pairs of electrons between atoms. And you should know these. Hang in there, there was a request. Do you see it now? If not, go back and look at the video. That's the nice thing about the video. You can always do instant replay after class. All right. Now let's get back to chemical bonds. You should know ionic bond, transfer 1 or more electrons from one atom or group of atoms to another atom or group of atoms. Covalent bond, the results from sharing of one or more pairs of electrons between atoms. Now, the octet rule, I'll never ask you, but all elements except hydrogen want to have 8 valence electrons. How do they do that? They either lose, gain, or share electrons, so they have 8 valence electrons. The exception is hydrogen, and that's 2 valence electrons is its octet. But everybody else is 8. Now, I left something from the last time I did this review. Now, charged ions, and ions are formed when element loses or gains electrons, and they do that to have the same number of electrons as the nearest noble gas. And here's an example: calcium, what ion is formed? And the question would be, draw or give the ion that calcium forms. Now, all this you don't have to write, but how do you figure it out? Calcium, you have to look at all the electrons and protons. Calcium has 20 electrons, 20 protons. Excuse me, where did I get that number? From the periodic table, the atomic number. Now, if we look at the periodic table, and let me check. Everybody see the periodic table? Thank you, nod up and down people, and thumbs up people. We look at calcium, it's here at 20. What's numerically the nearest noble gas? We have krypton, which is 16 away. We have argon, which is only 2 away numerically based on the atomic number. So it will lose 2 electrons to get to argon. And so if it loses 2 electrons, it will now have 18 electrons. You don't lose protons. Each electron is a -1, each proton is +1. And therefore, if we add them up, do the math, add it up, get a +2. And the actual answer for this would be that or that. Dr. White likes this way. This is the old way. This is the newer way, which I don't like. But on my test, either one would be correct. Now, an important concept for ionic compounds, actually all molecules, is the fact that for any ionic compound, the sum of all ionic charges must always be 0. All molecules in nature have a net 0 charge. And when you talk about formulas of ionic compounds, it indicates the number and type. So if I were to do the following, give the formula for an ionic compound made of calcium +2 and chloride -1. This is a +2. This is a -1, and it has to add up to 0. Oh, it doesn't. You can't change the charge, but you can change how many there are. And if I put a 2 there, it would be adding up to 0. And what that means is there's 1 calcium and 2 chlorines and calcium chloride. And you should know how to do that. We did that. Next, I talked about Lewis structures for molecular compounds or covalent compounds. And you have both bonded electrons, those are electrons involved, pairs, remember pairs of electrons are involved in a chemical covalent bond between 2 atoms. Non-bonding electrons are pairs of valence electrons not involved in electron sharing. Now, you should know And everybody together, single bond, one pair of electrons being shared between atoms. Double bond, two pairs of electrons being shared between atoms. Triple bond, three pairs of electrons being shared between atoms. So single bond, one pair, double bond, two pairs, triple bond, three pairs. And if I were to ask you, draw the Lewis structure for, say, oxygen, how do you do that? Oxygen, remember, Lewis structures are valence electrons, has 6 valence electrons. You find that from the top. And if I were to do this, and notice this oxygen has 1, 2 unpaired electrons, single electrons. This one has 2. And this oxygen says to that one, hey, I've got 2 unpaired electrons. You have 2 unpaired electrons. Let's share. The non-bonding electrons are still there. This has 2 unpaired electrons. The other oxygen has 2. And notice 2 pairs of electrons being shared. That's a double bond. Did you think about when you're breathing now, you're taking a molecule with a double bond? Remember that when you have an alkali metal, alkali metals always form an ionic bond. And that means it forms a cation, which is either potassium plus 1, sodium plus 1, or lithium plus 1. And so if I have something like lithium hydroxide, this will give up an electron to the OH. And we went through that. Go back and look at the video. And you should know how to do that. Quick thing about covalent ionic compounds. Can anybody think of an ionic compound you use in your daily life? Time's up. Please pass the NaCl and ACl, salt, table salt. If you brushed your teeth this morning, hope you did, it's good for your teeth. If you looked at the toothpaste, you'll see on the label ingredients near the end, sodium fluoride, that's ionic. And the calcium chloride I just showed you, that's ionic. Now, what would be some covalent molecules with only covalent bonds? Water. Another one is the oxygen I just inhaled, O2. The nitrogen I just inhaled, N2, and I won't do it. But if you burp, or if you look at a bottle of pop, I'm from Chicago, and the stuff with carbonation, the little bubbles, we call pop, not soda. Those little bubbles are CO2, carbon dioxide, and that's covalent, plus ammonia and a whole bunch of, ooh. Do you know sugar is covalent too? Next time you put sugar in your tea, hold on, I'm gonna have some. Wild blueberry today. That's covalent too. And you should know that. You should think about that. By the way, when you're not in my lecture or watching the video, you can still think about chemistry because chemistry is all around you. I stole that from SpongeBob. All right, next thing we talked about were moles and mole calculations. And let me ask everybody, can you see that on your screen now? Thank you. All right, you should know what is a mole. A mole is a chemist counting unit. Just like you go to a supermarket, you get a dozen eggs. Well, chemists use mole. Still have time to save for it. My birthday is the end of December. My favorite all-time birthday gift would be a mole of pennies. That's a lot of money. Now, important relationships. 1 mole of an element equals Avogadro's number. That should be superscript. Let's see if I can do it. All right, 1 mole of an element is Avogadro's number of atoms of that element. 1 mole of a compound equals Avogadro's number and molecules of that compound. Also, 1 mole of an element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of a compound is the sum of all atomic weights. When we went through chapter, I think it was 5 or 6 problems, we did all these. Remember, ooh, look out, you know what's coming. Remember to use your good buddy, your good friend, unit analysis. Love that siren whistle. Really, seriously, use your good buddy, your good friend, unit analysis. If you forgot how to do it, go back and look at some of my videos, which are all on YouTube. You know, I'm a YouTube star. You can have my autograph picture for $39.95 plus shipping and handling. No, not really. But anyways, seriously, use unit analysis, know how to use it. Also, on test 2, it pays to show your work. There'll be some large point problems, 8, one of them, 10 another, 6 another. And if you make a mistake, but you show your work, I say, oh, you just made a math error, or you put in, got the numbers transposed. I've seen all that. Well, if it's 10 points and that's, you knew how to do it, but you made a mistake. And as students say, a dumb mistake. Actually, I've never seen a smart mistake, but I digress. I'll get back on track. I'll only take off 1 point. If you get it wrong, the answer, and show no work, you get 0 points. So show your work. I gave you enough room on the test. Now, we talked about a chemical equation. Remember, at the base of the arrow, A and B are the reactants, which Dr. White will sometimes call starting materials. At the head of the arrow are the product or products. You should know how to balance the chemical equation. We went through that, and you should always have the same number and type of elements on each side of the chemical equation. You can't change the formula, but you can change the coefficients, the number in front of the formula. And my advice to you always, leave hydrogen, oxygen for last. And remember the even odd trick, which I showed you. All right, Rhea, we'll be doing that when I go through chapter 8. I'll show you how to do mole calculations, because that's part of the 3-step problem, okay? And if I don't, when we go over chapter 8 later today, yell at me and say, you promised. All right, what's the even odd trick? All right, let's do one real quick. Everybody see the reaction I just wrote on the white on my, all right. Now, you notice on this side, I have 2 oxygen. On this side, I have 3. There's no way I can multiply a whole number, the coefficient times 3 to get 2, and I can't multiply a whole number times 2 to get 3. So the trick is, what number do these both go into? Multiply them, 6. So if I want 6 oxygen here, what do? Put a 3 there. If I want 6 oxygen here, what do? I'll put a 2 there. And now on this side, I have 4 iron. And how do I get 4 iron? Put a 4 there. Put a 4 there. And that's how you do the even odd trick. You look at one side is odd, and the other even, multiply the numbers together. One other thing, remember, if you can divide all the coefficients by a number, do it. It should never be a multiple. If you had put 8 iron plus 6 oxygen is 4 ferric oxide, otherwise known as rust, we can say that's balanced, but notice I can divide each of these by 2. If you were to do it this way, where you could have divided everything and got whole numbers, that's wrong, and you'll get 0 points. And for balanced chemical equations, it's either right or wrong, 3 or 0. There are 4 of them on test 2, 12 points, like I promised. All right, now I'm going to be going through this in a little while when we do chapter 8, practice problem answers. And when we have a mass calculation, where if I were to ask you, if you react 20 grams of oxygen with an excess of iron, how many grams of ferric oxide do you make? You have to do mass calculations. And there are 3 steps. You can't do it in one step. And you have to, whatever you're given a weight of, you convert to moles. Now, using the balanced chemical equation, remember the coefficients are molar ratios. 4 moles iron, 3 moles of oxygen give us 2 moles of ferric oxide. And therefore, you can convert A moles to moles of B. And we'll go through this all in a little while after the break when I go through chapter 8 practice problems. And here we'll do finally, because you want to get grams, moles of B to grams of B. We've already done everything but 2 in practice problem. Remember, the coefficients are balanced chemical equation, are mole ratios. And the last thing I'll talk about in the review is limiting reactants. And just like I talked about, if I'm a company that makes this pen unit and I have 10 caps but 5 bodies, how many pen units can I make? 5. Because once I put 5 on the 5 bodies, I'll still have 5 caps left over, but I can't make any more of the whole pen unit. And that's because I run out of my reactant. It's limited because I only had 5 of these. Well, we do the same thing when you're doing a reaction and you only have a certain amount of each reactant. And what you do, and we'll go over that later today in chapter 8 practice problems, and that is determine the number of moles of products produced using the moles for each reactant. If I had 2 reactants, I'll do 2 equations, and the lower number of those 2 is the correct answer. This is all given to you, except for that, in important information. Now, if I look at the clock, first of all, any questions? 'Cause Hank? All right. My back is saying get up and stretch me. And this would be a good time to take a break. Normally do it. Come back at 10:50. That's when the big hand is on the 10. Or if you have a digital watch, that's when it's 10:50. And I'll see you in about 6 minutes or so, and we'll continue on. All right, let me get everybody back on track. One of my hobbies is model railroading. When I was very young, on special Sundays when my father wasn't working at the time, he'd take me to the train yards on the south side of Chicago, and we'd be outside the fence in the area where they'd bring in these monster steam engines. We'd spend 2 or 3 hours just watching them move them, turn them around on the turntable. Oh, I loved that. I was about 5, 6, and he loved trains, and guess what? So does Dr. White. All right, back to chemistry. Important thing. This morning, I uploaded your scores for the last lab, and for some of you who were had some labs outstanding, I uploaded those scores too. On the balanced chemical equation lab, the way I graded it, maximum 11 points. You got everything right, you got 11 points. If you got 1 or 2 wrong, you got 10 points. If you got 3 or 4 wrong, 9, 5 or 6, 8. I was being generous. But anyways, a lot of you got problem number 2 on the first page wrong, where it asked how many, what's the sum of all the coefficients in 1I? And the answer is 9. And what you forgot is when there's no number in front of a molecule, it's 1. Oh, by the way, I won't put anything like that ever on a test, but it still was good practice for you. Also, don't forget this Thursday, the lab we did last time, determining the formula for magnesium oxide will be due this Thursday by the end of the day sometime. All right, everybody see Dr. White's chapter 8, practice problem, mole calculations? Good. Now, let's look at number 2. We have this chemical equation, it's balanced, and it asks how many moles of ammonia are needed to make 4.58 moles of nitrogen. What are we being asked to find? Moles of NH3, ammonia. What are we given? Moles of nitrogen. Sometimes I might have also written this 4.58 moles of nitrogen with an excess O2. When you see excess, that means ignore it. And it's time to use unit analysis. What do we have to start with? This number. That's what we start with. What are we trying to get to? This number, moles of ammonia. Whatever you're trying to get to when you use your good buddy, your good friend, unit analysis. Anyways, whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes underneath. And where do I get these numbers? From the coefficients of a balanced chemical equation. This tells me 4 moles of ammonia react with 3 moles of oxygen to make 2 moles of nitrogen and 6 moles of water. Well, what's the relationship between ammonia and nitrogen? 4 moles of ammonia make 2 moles of nitrogen. And notice moles of nitrogen cancel out, and I'm left with moles of ammonia, which is what I want. These numbers, 2 and 4, the coefficients of balanced chemical equations are exact numbers and play no role in significant figures. So notice here I have 3, my answer is 3. Now, let's look at problem number 4. For the following chemical reaction or reaction, hydrogen plus chlorine gives you hydrochloric acid, that's HCl, and it's balanced. 1 mole hydrogen reacts with 1 mole of chlorine to give 2 moles of hydrochloric acid, HCl. Question is, how many grams hydrogen are needed to make 125.6 grams of HCl? You can't do this in one step. You need 3 steps. And I just, if you look at the, hold on, I just got rid of it. Let me open it up again. All right, where'd you go? There we are. All right, everybody see mass calculations for reactions? Thank you. This is an important information for test number 2. The 3 steps are whatever you're given in mass, which means grams, you convert to moles, which so a student who asked me earlier, we're going to go through this again. And then you convert whatever you just figured out the moles of A to moles of what you're trying to get, B. But you're being asked for grams, not moles. So we have to convert moles of B to mass of B. So let's take a look. Need 3 steps. We're trying to find grams of hydrogen, that's B. We're given grams of HCl, that's A. First step, convert the grams to moles. Use your good friend, your good buddy, unit analysis. Whatever I start with, whatever I have, I'll go here. Here are the units I'm trying to get to. This goes on top of the ratio. This goes underneath. Where do I get these? Up here, 1 mole of a compound equals its molecular weight, and the molecular weight of a compound is the sum of all atomic weights. And therefore, to put in the numbers of this ratio, 1 mole of HCl per gram of HCl, I have to do the molecular weight, sum of all atomic weights, which I have right here, 1 hydrogen, the 3 significant figure, 1 chlorine, 3 significant. Remember, you have to round it off from the periodic table. When you're doing an addition, you have the same number of significant figures past the decimal to the right as the number with the fewest. This has 2, this has 1. Round this off to the right. You drop the 1 because that should have 1 significant figure. Put that in here, do the math. I now have moles of HCl. 3 steps. Second step, moles of A to moles of B. Well, we have moles of hydrogen, but eventually, I'm off moles of HCl. We want to get to hydrogen, so it's moles of hydrogen. So I have moles of HCl, which I just calculated. I want to get to moles of hydrogen. How do I do that? Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. Where do I get these numbers? And I think somebody's going to tell me You can't see it. Hold on. Oh, the answer is Sylvia. Yes, I can. All right, can you see this now, Sylvia? Hydrogen is 101, chlorine is 35.5. And you add it up, you get 36.51. And that's how I got the numbers. Remember the atomic number on a periodic table, which I also closed. Teach me to close things when I need it. And by the way, thank you for your question. And where do you get the molecular weights? For that one, it was HCl, 1 hydrogen. Hold on, let me check. Everybody see the periodic table? Thank you. Hydrogen, you have to round this off to 3 significant figures. Keep the 1, keep the 0, keep the 0. Use the 8 to round off, that's 5 or higher. Drop that and change the 0 in front to 1. So that'd be 1.01. Chlorine, 35.453. How do you round that off to 3 significant figures? I'm going to let you try. Go ahead. I'll give you 5 seconds and I'll do it. Time's up. 3 significant figures, keep the 3, keep the 5, keep the 4. Use the 5 to round off. That's 5 or higher. Drop that 5, drop the 3, increase the 4.4 to 0.5. That's 35.5. And that's how I got this. All right, let's go back to where we're trying to go to moles of from moles of HCl to moles of hydrogen. Use unit analysis, put the moles of hydrogen on top, moles of HCl underneath. Where do I get those numbers? From the balanced chemical equation. 1 mole of hydrogen, remember when there's no number, it's 1, makes 2 moles of HCl. 1 mole of hydrogen makes 2 moles of HCl. I got it from the balanced chemical equation. 1 and 2 are exact numbers. This is 3 significant figures. My answer is 3 significant figures. But am I done? No, I have moles of hydrogen. I want to get the grams of hydrogen. So what do? I take my moles of hydrogen, step 3. Whatever we have in moles will now get their mass, which is grams. So I have moles of hydrogen. I want to get the grams of hydrogen. I use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath the ratio. And where do I get these numbers? 1 mole and grams of hydrogen. If you look at important information, test number 2, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight is the sum of all atomic weights. And therefore, 1 mole of hydrogen equals its molecular weight. Molecular weight is sum of all atomic weights to hydrogen 2 times, and we just did this, 101 gives you, remember this 2 is an exact number, 2.02. So we put that in there. Remember the 1 here, I forgot to mention the 1 here in step 1 is an exact number, 3, 3. The answer is 3. Now notice I have or. There are two philosophies for rounding off multiple step calculations like this involving multiplication division. One philosophy is, which I use, is round off at each step. The other philosophy is round off only at the very end. Which is right? Well, I think both are, but I like to round off at each step. But I'm not going to force you to do one or the other, your choice, and I'll always calculate it. If the answers are different, either one would be correct. Ooh, these were fun. Let's do another one. Ooh, let's do this one. By the way, C3H8 is propane. That's the gas, or liquid actually, but the gas you use with oxygen for your barbecue. And this also gives off heat to stall combustion. For the following reaction, how many grams of CO2 are made when you react this amount of C3H8 propane with an excess of hydrogen? Excess of something, ignore that. So we're trying to go from weight, grams, how many grams CO2, and we're starting with grams of propane, C3H8. You need 3 steps. See, it says it right here. Mass calculation for reactions. First step, whatever you're given in weight, you convert to moles. Second step, moles of what you just calculated, you convert to moles of your answer. Then you convert the moles of your answer to grams of your answer. Let's do it. So what am I given in weight? C3H8. I have to convert this to moles. I'll use unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. Where do I get the relationship 1 mole of a compound to grams of a compound? Important information. Test number 2 tells us 1 mole of a compound equals the molecular weight of the compound in grams, and the molecular weight of a compound is the sum of all atomic weights. And therefore, if I start 1 mole, so many grams of propane, C3H8, to make how many moles? I have moles per grams of propane. 1 mole equals its molecular weight. How do I get the molecular weight? Over here, propane, C3H8, has 3 carbons, 8 hydrogens. Each carbon to 3 significant figures is 12.0. Each hydrogen is 1.01. Multiply it, add it up. Remember, when you add up numbers, you get the same number of significant figures past the decimal as the number that has the fewest past or to the right of the decimal point. And therefore, this has 1, this has 2. Round this off, keep the 0, use the 8 to round off, 5 higher, drop it, increase the 0 by 1. So 1 mole per 44.1 grams, notice grams propane, C3H8, divided by grams of C3H8, cancel out, and I'm left with moles. And this is 4 significant, 3, the 1 is exact number. I answer here 3 significant figures. Are we done? No, we have to do step 2 of 3 steps. And if you look at important information, convert moles of A to moles of B. And now we have moles of propane, C3H8. We want to get to what? Well, we're trying to get eventually to grams of CO2. So B here is moles of CO2. Use your good friend, your good buddy, unit analysis. Whatever we're trying to get to goes on top, units. The units I'm trying to get rid of go underneath. Where do I get a relationship between moles of C3H8 H8 propane and moles of oxygen, O2, up here. And actually, moles of CO2. I said oxygen should be CO2. There is a C there. And if we look up here at the balanced chemical equation, top of the page, you see 1 mole of C3H8 makes 3 moles of CO2. The number in front tells you the molar relationship. 1 mole, when there's no number, it's 1. C3H8 makes 3 moles of CO2. So I can put that in there, 1 mole C3H8, 3 moles of CO2. These are exact numbers. And now, 3 significant, 3 significant. Am I done? No, I have moles of CO2. I want to get to grams of CO2. And now we'll do step number 3, convert moles of what we now have to mass, meaning grams of what you're trying to get the answer. And therefore, step 3, I have moles of CO2. I want to get to grams of CO2 and use unit analysis, your good buddy, your good friend. Remember, I'm trying to get the Guinness Book of World Record saying your good buddy, your good friend, unit analysis the most times this semester. I hope somebody's keeping count. I lost count. It's a lot. But anyways, grams of CO2 goes on top of the ratio. Moles go underneath. Where do I get the relationship? 1 mole to weight of a compound. 1 mole equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights in that compound. And therefore, what's the molecular weight of CO2? Oh, look, somebody was nice enough to put it on the paper. Thank you, Dr. White. You're welcome. And you have 1 carbon, 2 oxygens. It should be 16.0 times 2 is 32.0. Dr. White got lazy. Add it up, and the answer is 44.0. Remember, moles divided by moles, leave me with grams of CO2. Do the math, 3 significant, 3 significant. And notice I have down here both ways. That means if you round it off at each step, like Dr. White likes to do, or round it off at the end, you get the same answer. Now, if we look at number 8, for the following reaction, and make sure when you're reading problems and you're figuring out what are you being asked to find, make sure you write down or know what units you're being asked your answer to be in here. How many moles of water are made when you react 4.12 moles of C3H8 with 18.4 moles of O2? Secret. When you see a problem with a balanced chemical equation and the moles for each of the starting materials, that's a limiting reactants problem. I'll say it again. When you see the moles for both reactants and you're asked to find moles of product, that's a limiting reactants problem. Oh, I gave it away. And if we look at important information, limiting reactants problem, I don't have the word problem there, but determine the number of moles of product produced using each reactant. Again, determine the number of moles of product produced using moles of each reactant. The lower number is the answer. The lower number of these two calculations is your answer. So if we look at this problem, how many moles of water are made when you react 4.12 moles of, C3H8 propane with 18.4 moles of oxygen. What are we trying to find? Moles of water. We're given these two molar quantities plus the balanced chemical equation. That's important. And you have to do two steps. First of all, do two calculations, and the lower one is your answer. So if I start with propane, we have 4.12 moles of propane. We're trying to figure out how many moles of water. Use unit analysis. Moles of water goes on top. Moles of propane go underneath. Where do I get these numbers? Notice up here, for every 1 mole of C3H8, we make 4 moles of water. These are exact numbers, 3 significant, 3 significant. Now, the other reactant, we have to do the same thing. For every, we start with moles of oxygen. We want to get the moles of water. Use your good buddy, your good friend, unit analysis. Thinking I'm even going for the one lecture, Guinness Book of Records, World Records for saying that the most times. Moles of water go on top. That's how you use unit analysis. Moles of oxygen go underneath. Where do we get these two numbers? Where do we have a molar relationship of oxygen and water? And the balanced chemical equation. For every 5 moles of oxygen, we make 4 moles of water. For every 5 moles of oxygen, we make 4 moles of water. So I have 5 moles of oxygen, 4 moles. These are exact numbers. 3 significant figures, exact number 3. And now the lower number is your answer. If you look at number 9, we have ferric oxide rust reacting with carbon gives iron and carbon monoxide. Same thing, you need 2 steps. Here we're trying to find how many moles of iron react with so many, when you react so many moles of ferric oxide, Fe2O3, with so many moles of carbon. First one, moles of this to moles of our product. Use unit analysis. Where do I get these numbers? 1 mole of ferric oxide, Fe2O3, makes 2 moles of iron. And do the math, 3 significant exact number. Here's how many moles of iron you would have made. The second one, you look at, now we have 25.6 moles of carbon. How many moles of iron are made? Unit analysis, put this on top. Get rid of the moles of carbon by putting it underneath the ratio. And now, if we look at that, where do we get these numbers? Where's the molar ratio between moles of carbon, moles of iron? Up here. For every 3 moles of carbon, you make 2 moles of iron. For every 3 moles of carbon, you make 2 moles of iron. And you put that in there, 3 significant, and you get this answer. You now have 2 answers for limiting reactants. You get the lower number is your answer, which I have on there. And that's my going over problem set 8. Any questions on problem set 8? Tea break. Wild blueberry, it's good. It's from the Republic of Tea. I also like vanilla almond. Those are my 2 favorite teas. I've been drinking those for years from them. All right, any questions about any material on test number 2? All right, with that, let's go. We've got plenty of time. I think I'll go till midnight. No. let's look at Chapter 11. We've been talking about gases. I talked about pressure. We did some pressure problems. I also talked to other units, which we won't use in our class. Example, the air in your tires. You measure the pressure by PSI, pounds per square inch. 1 atmosphere equals that. My car tires on my Explorer, I keep it about 35 PSI, pounds per square inch, which is what the manufacturer. And we already did our practice time. All right, let's do some history. Long ago in the 1700s, early 1700s, I think most of you took history in high school. By the way, he's long gone. When I took it my freshman year, I had this, I can picture, I forgot his name, Coach Fabry. No, I didn't forget he was a football coach, junior varsity, but he taught history, and he was like, and I used to be staring out the window, doing everything, but watching him. And he got upset with me, but he couldn't do anything because I always got the highest scores on his tests, which I was listening and paying attention. I just wasn't watching him all the time. But history is an important thing, and I enjoy reading about history and learning about history. And back in the 1700s, early 1700s, what was a great advancement going on our planet and the world? And that's the Industrial Revolution. And what was an important part of the Industrial Revolution? To have the power to make power to move production equipment and make things. And first there was the water wheel. And if you go back and go to Google and look up in England, where it was the forefront of the Industrial Revolution, later on in America and throughout Europe. Not sure what was happening in Asia. You don't hear about it. I'm sure stuff was happening. But anyways, what was the next advance after the water wheel? The steam engine. And then later on, the gas engine, which to this day, if you have a car or if you've been in a car, which I assume every one of you in my class more than once has been in a car, SUV, truck, or bus, it has a gas or combustion engine. And that all deals with gas. And one of the important ways scientists, chemists, were able to harness the power of the combustion engine, or before that, the steam engine, was understanding important mathematical relationships between various parameters of gas. And these relationships are always true. And we call these the gas laws. And they're laws because they're always true. And we're going to do some of the gas laws. I'm going to teach you some of them. And can I have everybody's attention? Everyone, take a deep breath. Let it out. Take a deep breath. Let it out. I like the finger action there. Take a deep breath. Let it out. Are you all relaxed? Stay relaxed. We're going to do some algebra. Stay relaxed. I'm going to teach you how to do it, so it won't be that painful or difficult, but we will do some stay relaxed algebra. Reminds me of Monty Python's and the Knights of Ni. If you haven't watched the movie Monty Python and the Holy Grail, you're missing a lot. If you haven't seen, I think some skits on YouTube, Monty Python, the Holy and the Flying Circus, which was a TV program in England that was on Channel 11 for many years in the 70s and 80s. I was hooked on it. Anyways, relax. Let's look at the gas laws. Now, the first one was discovered by chemist Boyle, and it's called Boyle's Law. And we name things after people who made great advances. And you do not have to memorize this. And Boyle's law is the volume of a sample of a gas is inversely proportional to the pressure applied to the gas if the temperature is kept constant. Now let's talk later about remember to hand pump. What you should know how to use, because this will be an important information in test 3, is Boyle's law. P1 times V1 equals P2 times V2. And what does that really mean? P1 is the initial pressure. V1 is the initial volume. P2 is your final pressure. And V2 is your final volume. So what this really means is your initial pressure times your initial volume equals your final pressure times your final volume. P1 times V1 equals P2 times V2. And that's Boyle's law. All right. Zoom was just playing with me again. Everybody see a white screen? Everybody see Dr. White? That'd be white on white, and I'd be invisible then. Oh, that was awful. Depending on my mood. Going slow because I'm thinking about what numbers I should use in my head. All right, let's take a look at this. Let me decode it. If you have a cylinder, think of it like the piston in your car, cylinder, and the cylinder with a pressure of 752 torr and a volume of 8.75 liters, then what happens to the pressure if the volume is reduced to 6.51 liters? So what are we being asked to find? The volume, but it's the final volume, V2. What are we given? P1, the initial pressure, is 752 torr. We have V1, the initial volume, equals 8.75 liters. L is liters, it's a volume. And then what else are we given? We're given if the volume is Oh, wait a second. I had made a mistake. Somebody should have yelled at me. We're being asked, what's the final pressure? So this should be P2. Sorry about that. See, I told you I don't walk on water. And we're given the final volume, V2, equals 0.651 liters. Now, if you notice, all we have here to work with are volume and pressure. And immediately that should tell you, notice nothing about temperature. You should know that you need to use P1 times V1 equals P2 times V2. Now, what are we being asked to find? P2. And therefore, if we're going to solve for it, we want this alone on one side. How do we do that? Well, we got to get rid of the V2. I don't want that there. Now, let me remind you something I've taught you already. Anything divided by itself becomes the number one is gone. So if I want to get rid of V2, I'll divide by V2. That's going to be gone. But whatever you do to one side of an equation, you have to do to the other side. This cancels out, comes the number one. I now have P2 equals V1 times P1, or P1 times V1 over V2. Now, you don't have to do this, but Dr. White likes to. And good habits, I don't change. I'm going to rewrite it this way. All I've done is rewritten it this way here. And if we look up here, we see we figured out P1, oops. We look up here, P1 is 752 torr. V1 is 8 point, and all I'm doing is figuring out what volume is going P1 over V1 divided by V2, 8.75 liters. And then what is V2? Right up here, we figured it out. We read the problem, 0.651 liters. Now, guess what? You can use unit analysis again. How? Well, if you notice, liters divided by liters, anything divided by itself equals 1. This unit cancels out. I'm left with torr, which is a pressure, which means I'm on the right track. And now let me write these numbers down so I can pop them into my calculator. Let's get to my calculator. Everybody see my calculator? Spreadsheet? Can you see it? Thank you. All right, let me put in the numbers. and I'll hit enter. And here's the number I get. I'm going to put this in scientific notation. You don't have to, but and you get this whopping number 1.01-07527 times 10 to the fourth. Now, all the numbers I was multiplying and dividing were three significant figures. I'm going to let you try and round this off to three significant figures. Time's up. Keep the 1, keep the 0, keep the 1. Use the 0 to round off. That's 4 plus. Drop it. And therefore, the correct number rounded off to three significant figures is 1.01 times 10 to the fourth torr. And therefore, my answer is 1.01 times 10 to the fourth torr, which is like 10,000 torr, a little over 10,000. That's a big change from 750 to 10,000. That's a big change. Now, one of the things I've done throughout the semester, and now is the time to do it, is ask, or actually you should be asking the question, why am I learning this stuff? Well, the obvious answer is none of you are going to become chemists, but because someone said you had to take this course to get into a program or school. But why learn chemistry? What about the gas laws? Let's take a look at the problem we just did. Now, we had a cylinder, a warning, artwork. Dr. White never will ever go to art school. If I have a cylinder and I have a plunger so I can move it up or down, if I had a little valve here, when I pushed the plunger down, if I had air inside, what happened to the pressure? Well, it started here at 752, roughly 1,000 torr, and it ends up at 10,000 torr. So it's 10 times higher. So by pushing this valve in here down, by compressing it, I've increased the pressure. If you look at this, it's a hand pump. How many of you ever used a hand pump to inflate a bicycle tire, a volleyball, beach ball, football, other type soccer ball, or other ones? And how does a hand pump work? Guess what? You're using Boyle's law. By compressing the gas, lowering the volume, you've increased the pressure so it helps fill up the ball. Now, how many of you have ever gone to a gas station and used the compressor to fill your car tires with air? Well, what they have is a motor that has a cylinder and piston like that, or cylinder with the piston part that goes up and down, and it compresses it. And by doing that, it takes the atmospheric pressure and makes it a higher pressure. I bet you never thought when you're filling your car tires, your bicycle tires, or your soccer ball, you're doing chemistry. You're using a gas law. Now, let's go back and look at what I did, because we did some relax, take a deep breath. We did some algebra. I snuck it in there. We're trying to find pressure. We're given these units: initial pressure, initial volume, final volume. And therefore, since you only see pressure and volume, we're talking about a gas. Nitrogen is a gas. We use Boyle's law, which is P1 times V1 equals P2 times V2. But in order to solve for this, which is what we're trying to get, we got to get rid of this. And how do we do that? We use the fact that anything divided by itself equals the number 1. So I'm going to divide this side by V2. Whatever you do to one side, you have to do to the other. So I divided this side by V2. This cancels out. I'm left with P2 equals this. I rewrote it. And I just, because I took the time to figure out what each of these were, I put it in, did the math, and that's the number. I bet you never thought you were using one of the gas laws to either fill your tire or your volleyball. If you were playing volleyball, I haven't played that in eons. That was a fun game to play. We used to do that in high school and college all the time. Oh my gosh, if I look at the clock, we're just about done. I think we're done. I'm going to end a minute or two early. Don't tell the dean, because I don't want them to know I'm ripping you from your thumb knot. But anyways, remember, study for test number 2. Do the practice problems. They help. Try it on your own. Don't just look at the answer. That's not going to help you. Try it and then look at the answer. Remember, Wednesday night, I'll have my office hours. If you have any problems, stop by, say hello. And with that, I'll say, bye, gehen gesund, be healthy, and I'll see you on Thursday. We'll have our normal Zoom lecture. Bye.